The next hypothesis test is for the difference in population proportions. So, population proportions, that's when we had all those lovely fractions. It says, 2 popular drugs used for the treatment of whatever that is, an eczema. A random sample of 475 depressed individuals is selected and treated with Recithin or something, and 242 find relief from their depression. In a sample of 465 depressed individuals that's independently selected from the first sample and is treated with eczema or whatever that is, 205 find relief. Can we conclude at a 0.1 level of significance that P1 of all depressed individuals that find relief from depression is greater than P2? So P1 is greater than P2. Again, this is just like the other ones when we're comparing it to 0. Whenever we do the difference, we're going to compare it to 0. So P1 minus P2 would be greater than 0, would be my alternative hypothesis. P1 minus P2 is less than or equal to 0, then is my null. My null always has the equal in it. So on this one, when we're doing our test, we're doing a greater than, so we're doing that right-tailed test. The alternative is the greater than, the less than or equal to is our null. So, this time when we do our formula, we are going to do P hat 1 minus P hat 2. Again, we're minusing this 0 part over there, so we're not going to worry about the 0 because we know the difference is 0. But if you look in the book, they'll have that in there. Over the square root of P hat times Q hat. I didn't put my 1s and my 2s in there. I gotta look to see what number I stuck there. Oh, I got a formula for that. Find P hat and Q hat. Okay. Times 1 over N1 plus 1 over N2. Alright. So, P hat 1 is going to be the proportion from sample 1. On sample 1, 242 found relief out of the 475, right? 242 out of 475. So N1 in this case is going to be 475. And why I wrote that other number now, and I don't need it. On the second one, P hat for 2. On my second survey, 205 found relief out of 465. 205 out of 465. And 2 is the 465, right? All right. So, in order to find the p-value, just the plain p hat, we are going to do, that's why I wrote the x, the means. We are going to take, I wrote this weird. Look at this. Oh, the numerators, that's what that is for. Okay. We are going to take the numerators from each of these fractions and add them together, and then the denominators from each of those fractions and add them together. So I'm going to take my 242 plus my 205 over my 475 plus my 465. So take the numerators of each of your fractions, add them together, and then the denominators from each of your fractions, add them together. And so, when we calculate p hat, if you take 242 plus 205 over 475 plus 465, you get 0 point what? Make sure and you do it on the you're doing it on the Alex calculator, right? Mm-hmm. Yeah, so then you're going to have this on top and then highlight it and divide it by the bottom, right? The whole thing has to be on the bottom. Let's see what you got punched in there. 242 plus 205. Then highlight that whole thing, divided by 475 plus 465. Yep, that's the right number. 0.4755. Rounding that off anyway. All right. So, that means for Q hat, we are going to do 1 minus the P hat, 0.4755. So if you do 1 minus that value,
like 5,245.
0.5, what was that?
5,245.
245. Okay? So now we can go to our formula. We're going to do P hat 1 minus P hat 2. So 242 over 475 minus 205 over 465. And that's going to be over the square root of 0.4755 times 0.5245 times 1 over N1, which was 475, plus 1 over N2, which is 465. If I smush all of that in there. Again, all that has to go underneath the square root when you get that punched in. I forgot to do the type of test statistic. This is a z-test that we're doing when we do the proportion problems. So now we get to punch that crazy thing into our calculator. Click to the box first, yep. 242 over 475. Minus 205 over 465. Highlight that whole thing. Divided by square root. And then our two numbers we got, 0.4755 times 0.5245. And then in parentheses right behind that, we're going to have our 1 over 475 plus our 1 over 465. Parentheses. 1 over the 475, which was our N1, right behind there, plus, whoops, make sure you get right behind the line. Here we go. Plus 1 over 465. And then close the parenthesis on that. And hit equal. So we get what for the value of our test statistic?
2.106.
2.106, okay? So, we're doing a z-test. Again, on the z-test, it's P of z is less than, right, on your calculator. We want to do greater than, so since we're doing a greater than instead of a less than, we're going to do 1 minus that value. 1 minus P of Z is less than our 2.106.
Zero,
0.018. Okay, this is the percentage, the p-value. We're comparing it to the level of significance. And so if I have 0.018 and I'm comparing it to 0.01, is 0.018 greater than or less than 0.01? It is greater than. And if my test value is greater than my level of significance, what am I going to do? Accept the null. Accept the null. That means this is my true statement. This one is, whoops, this one down here is the one that is not true. So the true statement is it's less than or equal to. Can we conclude that the proportion of depressed individuals taking whatever that first medicine is who find relief is greater than the ones taking the second medicine? Can we conclude that it's greater? No, the greater than was the not true statement, right? So no, we cannot conclude it's greater than. That was not true. Doesn't want to stay there. Keeps moving. All right. Number 11. The General Social Survey is an annual survey given to about 1,500 U.S. adults selected at random. Each year the survey contains several questions meant to probe respondents' views of employment. A recent survey contained the question, how important to your life is having a fulfilling job? Of the 242 college graduates surveyed, 109 chose very important. Of the 133 people surveyed with the highest level of education of high school or less, 78 chose very important. Based on this data, can we conclude at a 0.5 level of significance that there is a difference between P1, which is the college graduates, and PT, which is or P2, which is those whose highest level of education was high school? So, is there a difference? P1 being equal to P2 or P1 being not equal to P2, but of course they're going to rearrange those and set them equal to 0, right? So P1 minus P2 either equals 0 or P1 minus P2 being not equal to 0. They are different, right? So again, this one's going to be one of those two-tailed tests because it's an equal and a not equal. So we had to start off with our p-hats. P-hat 1. P-hat 1. From those that were college graduates, 109 chose very important out of the 242 that was surveyed. 109 out of 242, which means N1 is my 242. For my second group surveyed, those that had high school education, 78 out of 133. So 78 out of 133 was my p-hat 2. N2 is my 133. So then we had to find just the plain p-hat, not P1 or P2. The plain p-hat value, we added the numerators together, added the denominators together, and figured out what our answer was. So my numerators, 109 plus 78. My denominators, 242 plus 133.
And 4987.
0.4987. My Q hat is 1 minus that value. So 1 minus 0.4987 would give me 0.5013. Okay, once we have all our data, we can now plug them into our formula. So on the top of our formula, we're doing P hat minus, or P1 hat minus P2 hat. So those two fractions we have. 109 over 242 minus 78 over 133. On the bottom of our fraction, we have the P hat times the, or the P times the Q. P hat times Q hat. So these two decimal numbers we got here. 0.4987. 0.4987 times 0.5013. And then in parentheses, 1 over N1 and 1 over N2. So 1 over 242 plus 1 over 133. I forgot to put my test statistic in there again. Z-test when we're doing proportions. Negative 2.521 it rounds off to? Okay. We are going to do the critical value. Again, we're doing a two-tailed test. So on this critical value, we're going to divide it by 2 since we have that two-tailed test. So we're going to use Z sub what number? 0.025. Right? We have 0.025 on this end, 0.025 on that end as far as our percentages. So if we do that, our critical values. $1.960 and negative 1.960 since we're doing that two-tailed test. So 1.960 would be the value here, negative 1.960 would be the value here. Our null would be in the middle. Our alternative ones would be if I'm on the two ends. So I'm going to look at my test value and decide where would my test value fall. Is it way to the left? Is it in the middle of those two numbers, or is it on the right side? It's on the left. Negative 2.521 is less than negative 9.60. So since it's on the left, we're in the H1 section. My alternative hypothesis is my true one, which means my null is not true. So the question says, can we conclude that there is a difference? Yes, we can. They're not equal, which means there is a difference. That is my true statement. Yes, we can conclude there is a difference. They're not equal. Number 12, same kind of thing. Got the whole thing? No, there we go. Large companies typically collect volumes of data before designing a product, not only to gain information as to whether the product should be released, but also to pinpoint which markets would be best targets for the product. Several months ago, I was interviewed by such a company while shopping at a mall. I was asked about my exercise habits and whether or not I'd be interested in buying a video/DVD designed to teach stretching exercises. I fall into the male 18 to 35-year-old category. I guess that, like me, many males in the category would not be interested in a stretching video. My friend Holly falls in the female older than 35 category, and I was thinking she might like the stretching video. After being interviewed, I looked at the interviewer's results. Of the 96 people in my market category who have been interviewed, 20 said they would buy the product. Of the 107 people in Holly's market category, 27 said they would buy it. Assuming that these data came from independent random samples, can we conclude at the 0.1 level of significance that the proportion from P1, which is all the mall shoppers in the male category who would buy the product, is less than P2, which is the ones in Holly's category? So we want to decide, can P1 be less than P2 is what the question says. The less than goes in for the alternative hypothesis, right? Of course, we're going to rearrange it so it's 0. So P1 minus P2 is less than 0 is my alternative hypothesis. P1 minus P2 is greater than or equal to 0, then it's my null. So we're doing a left-tailed test. We're checking less than for my alternative, which means my null would be over on this side, the greater than or equal to, right? So again, we have to have all our proportions and fractions and all of that fun stuff. My proportion for the first sample, for the males, what was my proportion for the males? 20 out of 96, right? Which means N1 is 96. For my females, which is my proportion for 2, (27 out of 107), which means my N2 is my 107. So now if I'm just doing my plain P hat, my plain P hat that doesn't have a subscript is going to be my numerators added together over my denominators added together. So I'm going to have 20 plus 27 over 96 plus 107. 0.2,
3, 1,
no,
6? I don't know.
2, 5, 2, 3 is what we should be getting, right? Wait a minute. Nope, I lied. I'm looking at the wrong number. You were probably right, and I'm telling you you're not. What did you get again?
0.236?
1, 5?
1, 5? Okay.
You got 1, 5 there? Okay. 0.2315. I was reading the wrong number. All right. P hat is 0.2315, which means Q hat is 1 minus that number. So if we do 1 minus 0.2315, we get 0.7685. Now that we have all those numbers, we can plug them into our formula to get our test value. So in the numerator of our test value, we are going to subtract our P1 and our P2, right? So 20 over 96 minus 27 over 107. On the bottom of that fraction, that's where I have that big long square root. I'm going to take my p-value, 0.2315, times my q-value, 0.7685, and then in parentheses, 1 over n1, which is how many I had in sample 1, plus 1 over n2, and I had 107 in my sample 2. So 1 over 96 plus 1 over 107. I forgot to write down that I was doing the z-test again. Since I'm doing proportions, I'm doing the z-test.
Negative 0.7421.
So we'll round that off to negative 7.4, or negative 0.742, right? 3 decimal places. Negative 0.742. This one we are finding the p-value. Since we're doing the p-value on our calculator does p of z is less than. We are doing a left-tailed test, so we're just going to put p of z is less than or negative 0.742. We don't need the 1 minus since it's not a right-tailed test, it's a left-tailed test. .229. We are comparing that percent to our critical value, which is 0.1. So 0.229 compared to 0.1 is greater than. And if my test value is greater than my critical value, I am going to accept the null. So this one's my true statement. This one would be not true. Can we conclude that the proportion of all mall shoppers in my market category who would buy the product is less than the proportion? Can we conclude that it's less? No, we're going to say that it's greater than or equal to. That's the true statement. The true statement was greater than or equal to, so we can't say it's less. No, we cannot conclude that it's less.